Okay, and the problem, it says there's a 13-foot ladder leaning against a wall. So it's going to make a triangle very similar to the problem that I sent you the video for. So that's 13 feet. It's fixed because that's a ladder. There's a wall over here. I'm going to call that Y. And then the distance that the ladder is away from the wall, I'm going to call that X. And so what they give me is that by the time the base is 12 feet from the house, so when X is 12 feet from the house, I know that the rate that the ladder is moving, which would be in this direction. If you think about a ladder falling down the wall that way, if the top falls down the wall, then the bottom, of course, goes in this direction as I've done here. So that's going to be dx dt. Okay, and so what I'm really going to try to find out is that at the instant that I'm 12 feet from the wall, they've told me that dx dt, and I'll just write that as x prime because it's easier to write, x prime of t is going to be equal to 15 feet per second. Okay, so as you recall, the first thing we have to do is get an equation that relates the variables. So we know that x squared plus y squared is equal to 169 because that's 13 squared. Second thing we need is an equation that relates the rates. We remember that both x and y are functions of t, so I'm going to have to use implicit differentiation. So I get 2x x prime plus 2y y prime, because I get a dx dt and a dy dt term, is equal to the derivative of 69 is 0. I can rearrange that and simplify, and so in this problem what I'm going to be looking for is what is the rate of change of the height, and so the height is y, so I'm trying to find, let me write this up here with my given stuff, I want to find dy dt, this is the unknown. So that means I'm solving for dy dt is just y prime, of course. So I need to solve this equation right here for y prime. So I'm going to push the 2x x prime term to the other side. So I've got 2y y prime is equal to minus 2x x prime. I'm going to divide both sides by 2y, and I get y prime is equal to minus x over y, and that's going to be times x prime. So let me take this to the other page here so we can work on that. So I've got that y prime is equal to minus x over y, x prime, and then I've been told that x prime at the instant that I'm working at is 15 feet per second, and that's when, let me see here, that's when the base is 12 feet away, so x is equal to 12 feet. Okay, I know x. I know x prime. The only thing I don't know is y, but I do know there's a relationship between x and y, and that is that x squared plus y squared is equal to 169. And so when x is 12, that's 144 plus y squared is equal to 169, or y squared is equal to 169 minus 144. That's 25. So y is equal to 5 feet. Of course, it would be plus or minus 5, but since it's a distance, it's 5 feet. So at the instance that x is 12, y is 5, and I'm given that x prime is 15. So y prime is equal to minus, and so x is 12, divided by y is 5, and x prime is 15, and so this is feet. That's feet. And the yx prime is going to be 15 feet per second. So that's good, the feet cancel, so I'm going to get feet per second. That's what I would expect because I'm looking for y prime. And so 5 goes into 15 3 times, and 3 times minus 12, that is going to give me minus 36 feet per second. So I've not answered all the particular questions, but everything is there in this that I've done for you, provided I've done all the algebra correctly. That should be able to help you answer all the questions that you have there from your course compass problem in 3.10.